Hi everyone, welcome to Unit 2.2b. This is day 2 of transformations. Okay, so today we're going to be looking at how we go from one transformed function to another. So last time we were saying how do we go from the parent to a transformed function, okay, and now we kind of want to look at some more difficult situations. Okay, so some things to remember. We always want to look at the inside first, then the front, and then the back. Okay, so we did kind of apply that on transformations day 1. Okay, other things to remember. When you have a negative in front of your function, it applies to the entire function. So I want to give you an example of that. So if I have a function, if I have this quadratic function and I want to reflect this over the x-axis, I would apply a -1 to the front, okay? So that would mean the entire function has to get multiplied brackets go around the whole thing. So really, after applying a negative, this would be my new function. Okay, because we have to reflect the entire thing over the x-axis. Okay, that's different, however, if I'm applying a coefficient. So let's say that I want to vertically stretch my function. So back to that same f of x, if I wanted to vertically stretch by 2, okay, that would not apply to the k value. Okay, that would stay at a +3, and I would just vertically stretch from the front. Okay, but a negative applies to the entire thing. Okay, and lastly, any value of a on the inside, we did see that that has to be applied with parentheses. So if I want to horizontally reflect over the y-axis, so again, back to my original function, okay, if I try to reflect that, that means a negative goes on the inside, okay, and I'm going to use parentheses in order to do that. So you could leave it with parentheses, or you could solve it out if you wanted. Either one of these is okay. All right, but those are 3 very important rules that you want to remember, because those are where most of our mistakes are going to come from. Okay, so the first type of problem we're going to look at is these chart problems. Okay, so I'm going to be given an original function, and now I want to move this to the right 4 units. So in order to do that, I'm going to be affecting the h value. Okay, so this is currently at h equals -6, because remember, that's the opposite for the h. So if I now move this to the right, okay, to the right 4 units, my h is -2, which means it shows up as the opposite inside. Okay, you could also just perform the opposite operation that they're being given. So if it says to the right 4 units, you know that means subtract 4 from what's inside. Okay, I now want to take this new, we always go from our newest step, we never go back to the original. I now want to reflect this over the y-axis. So that is a horizontal transformation, which means it needs to happen on the inside. And if it's on the inside, I have to use parentheses. Okay, and again, you could simplify this inside if you wanted to. Okay, so we're applying a negative on the inside to get this to reflect over the y-axis. Okay, same transformations, but now a new function. So however you want to think about this horizontal shift, Okay, if it's x minus 3 and I'm moving it to the right 4 units, it should be at x minus 7. Okay, so you could either think of this as h equals 3 and then plug it back in as the opposite sign, or you can subtract 4 from the value that's already there. Okay, and now to reflect it over the y-axis, we're going to apply that negative to the inside. Okay, and again, if you wanted to simplify, you could. Okay, let's try this again. Alright, so if you want to, here's your original function. If you want to pause this and complete your chart, I highly recommend that so you can test your transformation skills. Okay, so move this down 2 units. That affects my k. So I'm going to be at a negative 6. Okay, if we go from negative 4 on the y-axis and you move it down 2 units, that's a negative 6. In order to horizontally compress by 1/2, a horizontal stretch or compression uses the reciprocal. So we should really be using an a value of 2 here. Okay, so if I apply a horizontal compress inside, I'm using a 2. Anything that applies on the inside, you're using parentheses. Okay, if you wanted, you could simplify that out. Okay, and now I'm going to reflect over the x-axis. So remember, reflecting over the x-axis affects the entire function. So I want to make sure that I distribute that negative, 1 to the front and then 1 to the back. So I'm now at a plus 6 for my k value. Okay, so here's your second function. Again, if you want to pause, now would be a good time. Okay, moving this down 2 units. Well, my k value is currently at a plus 0. So to move it down 2 would just bring me to a negative 2. Okay, we saw that applying that horizontal compression means putting in an a of 2 to the inside using parentheses. And then reflecting it over the x-axis, you want to make sure you apply that to the entire function. Okay, but that's only for a reflection. It's not for a vertical stretch or compress. Okay, so the negative goes in the front, and it also changes the sign on your k. Okay, so this is our first type of problem for today, where we're just completing the chart. Okay, now our second type, we're essentially going to be given the first and the last step of the chart, and we're going to have to fill in the transformations that happened across the top of our chart. Okay, so think of this as my first and last step in the chart. Okay, and I want to think, well, how did I get from start to finish? Okay, so you definitely want to follow inside, front, back for this part. So from the inside, I start at x minus 5 and go to x minus 2. So what was my transformation? If I went from an h of 5 to an h of 2, we shifted to the left 3 units. Okay, now I'm looking to the front. Well, there's definitely something different in the front from the first to the last step. So a reflection over the x-axis was definitely applied. Now, we have to do a little intermediate step here. So if I reflected f of x, remember that means it has to apply to the entire function. So in between the first and the last step, after that reflection, that is what my equation looked like. So when I'm determining my k, if there was a vertical shift up or down, I have to take into account whether or not there was a reflection. Okay? Because even though from the first to the last step, the k value appears to be different, okay, it was not actually shifted up or down. The function was instead reflected, and that accounted for the change in k. So these were actually the only two transformations that occurred on this function. Right, so again, this is my first step. F of x is first. And this was my last step in the chart. And I want to see, well, how did I get? What were the in-between equations and the in-between steps? Okay, so in my first step, I have an h of -4. And in the last step, I'm at an h of 0. So how did this graph move? It was shifted to the right. Okay, now we look to the front. So I see there's two things happening in the front. There's a negative and there's also a value. Okay, so the 0.5 in the front is going to perform a vertical compression. Okay, and the negative is going to perform a reflection. So reflected over the x and vertically compressed by 1/2. Now, we want to actually apply that reflection for an intermediate step here, because we know that the reflection applies to the entire function, whereas the compression does not. Okay, so when I reflect, so in between the first and the last steps, I'm now at a k value of -2. To get to my last step here, I went from a k of -2 to a k of -1. So a transformation had to occur, which was shifted up 1 unit. Okay, so I'm going to bring back that text. Okay, because the reflection applies to the entire function, but the compression does not. The 0.5 then, so if this was, I'm going to number these steps. So let's say this was my first step. Okay, and then we would have performed shifted to the right. Okay, so step 2 would have made this equation. Okay, we just shifted our h. Step 3 was then reflecting it. Okay, so this would have been the third step in my chart. So now I reflected it over the x-axis, and that applied to the entire function. Okay, but step 4, vertically compressing it, okay, which just means putting 0.5 in the front, that did not apply to the entire function. That didn't change my k value. So then to get to step number 5, which was the last, I actually had to change my k value. To get from a -2 to a -1, I had to perform a transformation, which was to shift this up 1 unit. Okay, so that differentiation between a reflection and a vertical stretch or compression is very difficult. Okay, let's try one more. So this is my first. Here's my last. So in my first step, I'm at an h of 3, and in my last step, I'm at an h of 0. Okay, so horizontally, how do I get from 3 to 0? I shift to the left. Okay, so then if you wanted to write down the equations in order, that might help you as well, as if you were trying to complete the chart. Okay, so this was my original, step number 1, my first. Step number 2, I shifted it to the left, so that just changed my h. Okay, I also see on the inside, I now have a 2x. Okay, a coefficient on the inside is going to be a horizontal stretch or compress. And remember, we have to use the reciprocal. So we're really talking about an a value of 1/2. So a fraction is going to compress. So this is a horizontal compression of 1/2. Okay, and now lastly, how do I get from a k value of +1 to my last step leaves me with a k value of -5. Okay, and that is by shifting down 6 units. Okay, I think the hardest part of these transformed to transformed problems is applying the -1 to the entire function and applying the coefficient to just the front. Okay, making that distinction and applying these intermediate steps like you see on the right, I think is the hardest part. So I do suggest try and set up a chart like the first couple of problems that we did, because I think that that helps you to get from the first function to the last.